In this, I discussed some of the flow regimes or different types of flows that we would see in a gas liquid flow, right? I mean, going from left to right, we see 5 different flow regimes. And we would see this depending on the volume fraction of your dispersed phase and depending on the velocity at which your dispersed phase is moving, right? I mean, picture here, I mean, it shows your gas bubble traveling up in the axial direction in a liquid phase, and these gas bubbles, they are well separated. They don't seem to be interacting with each other. But as you move to the right, so the volume fraction of your gas bubbles has gone up. You see a lot more bubbles. They are in contact with each other. They might be colliding against each other. There could be some other phenomena like bubble coalescence that could be going on in the system. Moving on to the center one, I mean, you see instead of individual gas bubbles, now we have some individual gas bubbles, but then we have a big slug that is being transported up, right? I mean, the physics that are going to be important in each of these cases is very different. And you need to know which regime you're operating in to make sure that you choose the right CFD approach, right? So in the first one, you don't really need to consider the interaction between bubbles. In the second case, the interaction between the bubbles might become important. In the third case, what is more important is to correctly predict your size of slug, because that is what governs the transport of your dispersed phase within the system, right? So you need to have some idea of what is important and what might be going on in the system to be able to choose the right approach. So going on, let's look at some of the flow regimes that we might see in a fluidized bed for gas solid flow, right? I mean, so what we see here is we have a bed of solid particles, and we inject gas from the bottom. Again, we see a lot of different flow regimes depending on my gas flow rate in the system, right? I mean, at low gas flow rates, all the solid particles are evenly suspended. But as I increase the flow of gas through the system, we start forming these bubbles that rise through the solid bed. As I inject more and more gas, the bed becomes more turbulent. So depending on what your gas injection flow rate is and your properties of the solids, such as its diameter, its density, and so on, you'll have an estimation of what kind of flow you might get in the system, and depending on that, you choose the right CFD approach to solve your problem. So this is again an example of what you might see in a real system and how you would use the information to make sure that you choose the right CFD approach.